Hi everyone, welcome back to the channel. This video is the extension of the previous video, which was on maximum power transfer theorem. If you haven't checked that video, you can check that in the link provided in the description box. In this video, I will be solving three more problems which are bit different from what we had solved in the last video. So let's start with the first problem. Problem is we have to calculate the value of RL for which power transfer is maximum. Also calculate the maximum power. This one is the load resistance. Here we have a current source. And here we have another voltage source of 20 volts. The current source supplies 2 ampere. This resistance has value 10 ohm and this one is of 20 ohms. So we need to find out RL. Since this is a complicated circuit, we need to replace it by its Thevenin equivalent in order to calculate the value of RL as well as to calculate the maximum power. So let's start by finding out VTH. So first step is we need to find out VTH. For finding out VTH, we need to remove this load resistance. And if you have any confusion in understanding that how to obtain the Thevenin equivalent of any circuit, then you can check the videos on the Thevenin's theorem. The link for that is also provided in the description box. So this 5 ohm resistance, 2 ampere source, 10 ohm resistance, then 20 ohm, they will remain as it is. 20 volt source over here. Here we have 80 volt source. And these are the load terminals where we need to find out VTH, for which I have assumed a polarity. Now how can we calculate VTH? We can apply KVL in this loop, in this open loop, by assuming that the voltage between these two terminals is VTH. We can also apply KVL over here. But for that, we need to know that what are the currents through these resistances. Now how can we calculate the current? We can apply mesh analysis. Let's say current I1 is the flowing through this mesh. I2 is the current flowing through this mesh. Now since we have a current source of 2 ampere connected in mesh 1 in the outer branch, so we get the answer of I1 directly as, as 2 ampere. Current through the first mesh is 2 ampere. For finding out current I2, let's say this is I2, we need to apply KVL in mesh 2. For that I am assigning the voltage drop polarity as per the direction of I2 plus minus plus minus. So if we start from the 80 volt source, as negative sign is coming first, so minus 80. Then drop across 5 ohm resistance is 5 I1. Then drop across 10 ohm resistance 10 into resultant current. So not I1, it should be I2 because this current in mesh 2 is I2. Then current through 10 ohm resistance is I2 minus I1, which is in same direction with I2. Then drop across 20 plus 20 into again current through 20 ohm resistance in direction of I2. It will be I2 minus I1. Then we have 20 volt source for which positive sign came first, so plus 20 over here. Now in this equation, we need to use the value of I1 as 2 ampere. So minus 80 plus 5 I2 plus 10 I2 minus 10 I1 plus 20 I2 minus 20 I1 plus 20 equal to 0. Minus 60 on this side, it will become plus 60. Then we have the terms of I2, 1, 2, 3, 35 I2 minus 30 I1. So this will give us the value of I2 as 120 by 35, which is 3.428 ampere. So this is the value of I2. Now in order to calculate VTH, let's say we apply KVL in this open loop. So when we apply KVL in this open loop, if I start from 20 volt ohm resistance, then plus 20 into I2 minus I1 plus 20, that is the voltage source voltage, minus VTH equal to 0. So VTH will be equal to 20 plus 20 into I2 minus I1. I2 is 3.428 and I1 is 2. So this will give us the value of VTH as 48.56 volts. So next step is we need to calculate RTH. For calculating RTH, the current source has to be replaced by open circuit. The two voltage sources, they will be replaced by short circuit. 5 ohm resistance and current source replaced by open circuit. 10 ohm resistance, 20 ohm resistance. This voltage source replaced by short circuit, and this 20 volt source again replaced by short circuit, and these are the load terminals where we need to calculate the equivalent resistance. Now the equivalent resistance is, it's clear that there are two branches which are connected in parallel. So RTH is actually parallel combination of 20 and 10 plus 5, 15. 10 and 5, they are in series and that their resultant is in parallel with 20. So RTH is 8.57 ohm. So for maximum power transfer, RL should be 8.57 ohm, and then we need to find out PL max as well, which is VTH square by 4 RTH. The value of VTH was 48.56. upon 4 into 8.57. Its PL max is 68.78 watt. So what we see that the maximum power transfer formulas are the last step. The main focus is on how to obtain the Thevenin equivalent. The second problem which I am considering over here is for the network shown in figure, find the value of RL for maximum power transfer and also calculate maximum power. The circuit is a 10-volt source, 10 ohm resistance, 4 ohm, 4 ampere, another voltage source 12 volts, 2 ohm, 8 volt, 5 ohm, 2 ohm, 6 volt, and here we have resistance RL. Now this circuit has 5 different sources, so it's a bit complicated circuit. We need to replace it by its Thevenin equivalent. For that we need to calculate VTH and RTH. So our first step is calculate VTH. For calculating VTH, the whole circuit will remain same except the load resistance. Every resistance, every source, they will be there in the circuit as it is. This is the load resistance terminals where we need to calculate VTH for that, which I have assumed this polarity 10 volt, 10 ohm, 4 ohm, 4 ampere, 2 ohm, 12 volt, 5 ohm, 8 volts, 2 ohm, 6 volts. Now how can we find out the VTH? For that we can apply KVL in this open loop. In this open loop the current will be 0. So the current through 2 ohm resistance will be 0 and there will be no drop. We need to find out that what is the current through this 5 ohm resistance. For that we can apply any method. We can go with nodal analysis, we can go with mesh analysis, or we can even apply KVL in any suitable branch. So if I assume that the current in this loop is I, then current through 2 ohm is I, current through 5 ohm is I, and I can apply KVL in this loop. It's not a mesh, but it's a loop. We can apply KVL in this loop, and that will actually simplify our solution. We just need one equation and we will get the value of I. So for this loop, starting from 10 volt minus 10, then voltage drop polarity for 2 ohm and 5 ohm will be like this, plus 2I plus 12 plus 5I plus 8 equal to 0. So from here, the value of I is 10 by 7 ampere. Minus 10 by 7, sorry. It's minus 10 by 7 amperes. When you solve this equation, you will get the answer of I as minus 10 by 7. And for finding out VTH, we need to apply KVL in this open loop. Drop across 2 ohm is 0 because there is no current. Basically, the current through 2 ohm resistance is 0 since it's an open loop. Minus 6 plus VTH minus 8 minus 5I equal to 0, or VTH is equals to 14 plus 5I. So it's 14 minus 5 into 10 by 7. Since the value of I is negative, so it's minus 5 into 10 by 7. So VTH is 6.857 volts. This is the value of VTH. Next step is we need to calculate the Thevenin resistance as well. For calculating RTH, 10 volt source, 12 volt source, 8 volt source, 6 volt source, they will be replaced by short circuit, while this 4 ampere source, it will be replaced by open circuit. So let's draw that equivalent. 10 volt short circuit, then we have 10 ohm resistance, 4 ohm resistance, current source replaced by open circuit, 2 ohm, 12 volt replaced by short circuit, 5 ohm, again 8 volt replaced by short circuit, 2 ohm, the 6 volt source replaced by short circuit, and we need to calculate equivalent resistance seen from these terminals. Now this 10 and short circuit, they are in parallel. So basically this 10 ohm will get short circuited as well. 4 ohm is not there in the circuit. So what we have, 2 and 5, they are in parallel. Their resultant is in series with this 2 ohm resistance. This 2 and this 5, they are in parallel. 2 in parallel with 5, and their resultant is in series with 2. So RTH is equal to 3.429 ohm. For maximum power transfer, RL should be equal to RTH. So the value of RL should be 3.29 ohm, and PL max, which is VTH square by 4 RTH, 6.857 square upon 4 into 3.429. So PL max is 3.428 watt. So this is the power which is delivered to the load. So last problem is for what value of RL the power transfer is maximum. Also calculate the maximum power. So we need to calculate the value of RL for which the power transfer to the RL is maximum. Now the circuit is and this is a circuit where this resistance is a load resistance 6 ohm, 2 ohm, 4 ohm, 3 ohm. Again, we need to replace this circuit by Thevenin equivalent. So we need to calculate VTH as well as RTH. So our first step is calculate VTH for which RL should be removed from the circuit and rest of the circuit will remain as it is. These are the load terminals where we need to find out VTH. Six ohm, 2 ohm, 3 ohm, 4 ohm, plus minus VTH. So this is our assigned polarity. Now how can we find out the VTH? By applying KVL to this open loop. Again, for this we need to apply KVL to this mesh as well as this mesh so that we can find out that what is the current through 6 ohm and 2 ohm resistance. The current through this open loop will be 0, but the current will flow through the 6 as well as 2 ohm resistance because of these two meshes. So let's say this current is I1 and this one is I2 and then apply KVL. Mesh 1 starting from 72 volt source minus 72 plus 6 I1. This will be the voltage drop polarity for 6 and then for 3. Then 3 into resultant current in direction of I1, that is I1 minus I2, and this should be equal to 0. So this will give us the equation 3I1 minus I2 equal to 24. This will be the simplified equation for mesh 1. Then mesh 2, for mesh 2 again assign the voltage drop polarity as per the direction of I2, plus minus plus minus plus minus. Starting from this 2 ohm, 2I2 plus 4I2, then 3 into resultant current in direction of I2, that will be I2 minus I1 equal to 0. So when we solve this equation and simplify, we get minus I1 plus 3I2 equal to 0. So this is our second equation. Now the solution of these two equations will give us the value of I1 and I2. I1 is 9 ampere and I2 is 3 ampere. Now in order to find out VTH, let's start from VTH only. plus VTH. Now this is in the open loop. Then drop across 2 ohm. We had already marked the polarity according to I2, since I2 is the only current which is flowing through this 2 ohm resistance. So let's write the voltage drop as per that polarity only. So it will be minus 2I2. Similarly, again for the 6 ohm, only current I1 is flowing. We had already marked the polarity as per that current direction. So it will be minus 6I1 equal to 0, or VTH will be equal to 2I2 plus 6I1. I2 is 3, I1 is 9. So VTH is actually 60 volt. 6 plus 54, it's 60. So next step is we need to calculate RTH. We have only one source, one voltage source, that should be replaced by short circuit. And then we have different resistances, and between these two terminals we need to calculate RTH. Now how these resistance are connected, it's difficult to understand from here. If we have circuit like this, then it's better to draw the circuit again. I'm marking this one as terminal A, B. Let's say this is C and this one is D. Now A to D, these two are the same terminals since we have a short circuit. So let's redraw the circuit. For redrawing the circuit, we need to calculate the equivalent resistance between A and B. So I'm drawing B over here. Here we have A, and then D over here, and both are same. A and D are same. Let's say we have terminal C over here. Now from A to C, we have one resistance of 6 ohm that we had drawn over here. Then C to D, 3 ohm resistance. So let's say this is how we draw C to D. Then we have a resistance between B and C as well, that is 2 ohm. 2 ohm resistance. And we have one more resistance of 4 ohm which is between B and D. B and D, 4 ohm. Now this one is quite easy to calculate the resistance. These two are same terminals, so it means 6 and 3 they are in parallel. So its equivalent is like 2 ohm. 6 and 3 they are parallel combination. 6 into 3 divided by 6 plus 3, 9. 18 by 9 again 2 ohm. So this is how B and A and D both are same, so D got eliminated. From here we have 4 ohm resistance. Now it's very easy. 2 and 2 they are in series. It's in parallel with 4. So our equivalent is RTH. We can write as 6 in parallel with 3. Their resultant is in series with 2. And this is in parallel with 4. This is how we can write for RTH. So 4 in parallel with 4, obviously this will be 2 ohm. So the value of RL for maximum power transfer, it should be 2 ohm, and then the value of maximum power is VTH square by 4 RTH is 60 square by 4 into 2, 450 watts. In all these problems, what we had seen that for obtaining the maximum power or the value of RL, we need to obtain the Thevenin equivalent first. So it's important to know that how to obtain the Thevenin equivalent for solving the problems of maximum power transfer theorem. I hope these problems are helpful to you to understand the maximum power transfer theorem as well as the Thevenin theorem. If you find these videos helpful to you, please consider subscribing the channel. Thanks for watching the video.